I saw a good repository and I wanted to show you. This repository actually helps you to choose the best LLM based on your machine architectures and your resources. So if you run a local LLM, you've probably done this before. Open a Hugging Face, sort by model size, and download the biggest model or whatever it is, because generally it was like you were multiplying some numbers to figure out that how much RAM or VRAM this model is going to take from your system. So you then if the number matched, you would have downloaded that model. But this repo, this tool, it's very good. Like, it will find the best model, the open source model from the Hugging Face, and it will tell you that which one of these model is best for you, and which one is gonna work better on your system, and which one is much more efficient, much more faster, and what loads do you have in your system, you will have in your system. And this tool is WhichLLM. It's pretty fun, so we're gonna look at this. And this is a package, it's a official package on PyP, so you can directly download it and install it on your system using UV or UVX for temporary installation. Before we run it, I want to look at this. It's a workflow, so we can see what it's actually doing. It starts by detecting the hardware, your GPU, available VRAM, CPU, system memory. Then it pulls live model metadata from Hugging Face here and combine it with the benchmark result from sources like LiveBench, Artificial Analysis, Aider, Chatbot, or not, all of this. So instead of answering the question of what is the biggest model I can fit in my system, this tool is trying to answer, given this exact machine that you have or we have, what's actually the best model to run. The project is completely open source, MIT license, actively maintained. I mean, like, the 2 weeks ago they had a commit, so it's new and it's actively maintained. And it had like 5k star. And I also looked at the source code. I didn't see any kind of code running or malicious code running, so it was pretty good and safe. The README is very well designed, so you can use the README and run it and use the tool. Is pretty much all of it. It's here, all of the things that you need for your job. So now let's see what happened on my machine. I already cloned the project. I already installed it on the virtual environment, so I'm gonna run it directly. Ranking the models, and this is it. This is the result. This laptop has a RTX 4050 with 6 GB of VRAM. It's not a monster actually. So I'm curious what coming up. We can see that GPU 0 is NVIDIA GeForce, GPU 1 is Raptor Lake P UHD graphic. My OS is Linux. Headroom, this is a very good thing because he actually considered a headroom of the RAM, the VRAM. So it knows that some of the VRAM is going to be reserved. So it's a good decision that keeping that headroom in the mind, because you're not going to use that headroom. Otherwise, your system will be lagging. So here is the ranking of the model that they are good for my system, the recommended model. This is the table. The first one is Gemma 4, but the thing is, it's pretty good, right? 26 billion parameters, 26 like 0.5 billion. It's pretty good, but the interesting part is this: fit VRAM. It's partial, so that means the model doesn't actually fit inside the GPU memory. So more than half of it going to spill over into the system RAMs. So it's not going to use only the GPU, which usually means much slower and much less predictable performance. And that is why that here, after this number in the speed column, we have a question mark. We cannot say with the confidence this speed is the exact speed. So that is why that you need to also consider these things in this table. Even though this is a number one model for my system, but the performance of this model on my system is unpredictable, even though here we have 26 tokens per second. And another good thing is that here, even though this model is the first rank, but the second model with a little bit less score, 62, 64, it's a very little difference between these two, and it's because of this column is a partial fit, but this model is a full GPU fit. So it says that, okay, technically this model win, but I wouldn't bet too much on that. So you can also consider the second one because of these reasons, the predictability and also the load on the GPU. And also here, top pick confidence. It says that if you want to pick this one, the confidence of picking that is low. Why? Because as we said, it has a partial load, so half of it will be loaded into the VRAM, into the system RAM. So, okay, this table is showing everything, but let's make the recommendation a little more realistic. I don't want a models that partially split into the RAM. I only want a model, for example, someone only wants models that fit completely inside GPU memory, and I only want ones that are actually comfortable to use. So there is also a command to handle this, is I think this one, the GPU only, combined with the speed, I think. So we can say GPU only and speed, the reasonable speed, and usable. So now all of the models, they will be loaded fully into the GPU. Here we have Q1 38 billion. But more interesting part is that the top pick confidence right now is high, but previously it was low. And the difference between the first and second model is pretty a lot. It's too much different between these two. So you can pick the first model with much more confident. And every recommendation here, as I said, fully fits in a VRAM. And they're expected to generate somewhere around 26, you can see it here, 26 token to 28 per second. These are the recommendations that should actually behave the way that you'd expect. So they are more predictable on the performance. And here you can see the benchmarks. Okay, there's another details I almost missed, like this model here. It's exactly the same as this one. 5 gigabyte, 5 gigabyte, full GPU, 8 billion. But the difference here is this model just packaged as a GGF-UF by another uploader. And also this maybe means that the benchmark wasn't measured directly, the score was inherited from the original model family. It's a tiny detail, you know, but that is why that you have a very huge difference here between the scores, but they are practically the same models. One thing I appreciate is that you're not, with this tool, you're not locked into the automatic hardware detection. Maybe you're using an integrated GPU, or maybe unified memory wasn't detected the way you'd like. Maybe there wasn't detection of your hardware here. So at that time, you can change the details of the hardware and simulate all of these results over the new hardware. So you can override everything. And this is a command here, this one, that you can use it. This command, for example, is that I'm telling the WhichLLM that I'm pretending that I have an 8 gigabyte VRAM budget and about 68 gigabyte per second of memory bandwidth. So it's really nice, a way to experiment without changing the hardware, or maybe you have in mind to buy something else. So with these things you can experiment different hardware. So I've changed the first GPU 0 to be 8 gigabyte with 68 bandwidth. This will be the result as you saw. We have also the dash dash feed GPU is the same thing as dash dash GPU dash only. It's the same thing practically. Okay, now let's see fully that what is this table actually means. Here I use this one. So here, there's a lot of information packed into this table. You have a rank here. The first column is simply the ranking. Everything is sorted by the final score. So the rank one has a higher score. The next column is model. This is a model name from Hugging Face along with parameter count. So you have Q13 8 billion, DeepSeek R1 DeepSeek Llama 8 billion, this one 8.2 billion parameters, 7.6 billion. And I think for the model with the architecture of mixture of experts, you also can see the activation, the amount of parameters that they're active during the inference. Yeah, for example, here is this model is 26 billion, but only 3 billion of it, the parameter are active during the inference. Then we have a quant column, which is a quantization column, tell you which GGUF quant it's recommending. This one is Q3KM. Lower bit quants need less memory, obviously, and usually run faster, while higher bit quant preserve more quality. Hey guys, thanks for watching the first part of explaining these tools. In the second part, we are going to explore other sections of these tools.